All right, in this last example, we're going to again look at dominance to predict the long-run behavior of these functions. And so just like when you have a polynomial, or sorry, a rational function with polynomials in the numerator and denominator, remember we looked at the highest power of x in the numerator and denominator because those dominate everything else in the long run. And we can do a similar thing with this. So if we look at as x goes to, let's look at positive infinity, right? Then 2 to the, whoops, the numerator is 3 to the x, right? So 3 to the x and 2 to the x will dominate. Dominate. Okay? So what we can do, just like we did with rational functions, we can look at just the ratio of 3 to the x over 2 to the x and just ignore the plus 12 and the minus 11 because compared to infinity, 12 looks like a really small number. Okay, so let me erase my commas, getting into my way here. All right, so this I can rewrite as 3 halves to the x, right? I have two different bases, but they have the same power, so I can rewrite that as 3 halves to the x. That's greater than 1, and so this is going to go to infinity. All right, so that's what I would predict the behavior of this function to be as x goes to infinity. Then f of x is going to go to infinity. So let's look at as x goes to minus infinity. All right. So now what's going to happen? What's going to happen? When we put in a negative value of x, this 3 to the x and the 2 to the x, right? If x is negative, those are going to go to 0. All right. So so let me write that down. 3 to the x goes to 0 and 2 to the x goes to 0. All right. And all we are left with is just the constant. So f of x is going to look like 12 over negative 11, right? So that's what's going to happen. We're going to have an asymptote, a horizontal asymptote at 12 elevenths, negative 12 elevenths. All right. So, all right. So part B, this is it's the same thing, only the 2 to the x and 3 to the x are swapped, right? So again, I can look at as x goes to infinity. Again, 2 to the x and 3 to the x will dominate. Okay, so again, I'll just ignore the constant because if 2 to the x and 3 to the x are really, 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 really big, then I can kind of just ignore the 12 and the 11 because it doesn't really matter if they're so small. So it's going to start looking like 2 to the x over 3 to the x, okay, which I can rewrite as 2/3 to the x. And as x gets larger and larger, because 2/3 is less than 1, I raise it to bigger and bigger powers, it's going to go to 0. Okay, so as x goes to infinity, this function would go to 0. And let's look at as x goes to minus infinity. All right, so just the same thing that happened before. 2 to the x goes to 0, right, because x is negative, right? So it's essentially like 1/2 to the x. And 3 to the x goes to 0 as well. So what's f of x going to look like? F of x is going to look like, it's going to go to just the constants again. So we have 12 over negative 11. All right, and so we have the same horizontal asymptote as we did before. So we have two different horizontal asymptotes, which is interesting. We have one at 0, one at 11, or 12 elevenths. All right, so let's look at the next one here. So here again, we have a 2 to the x in the numerator and a 2 to the x in the, or 3 to the x in the denominator. All right, So let's first of all look at as x goes to infinity. All right, again, 2 to the x and 3 to the x will dominate. Okay, dominate. So they're getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, even bigger than x to the 10th. All right, here before we had constants, but now we have an x. So this x to the 10th is getting bigger and bigger and bigger and bigger and bigger too, but just not as fast. So, but it's still going to dominate in the long run because we're talking about going to infinity here. So, so 2 to the x is going to grow a lot bigger than x to the 10th. And so that 2 to the x is going to dominate in the numerator. So f of x is going to look like, again, the same as before, 2 to the x over 3 to the x. And that's equal to 2/3 to the x. And that goes to 0 because 2/3 is less than 1. So it's decaying. All right, and then let's look at the other side as x goes to negative infinity. Now again, 2 to the x goes to 0. 3 to the x goes to 0. All right, so what's happening there? And x to the 10th, well, x to the 10th is going to go to infinity, right? X to the 10th goes to infinity. All right, so we essentially have sort of a almost like an asymptote, but we're dividing something going to infinity, and dividing by 0. All right, so but we could rewrite this as let's try and rewrite it as 2 to the x plus x to the 10th times 3 to the minus x, right? And now 3 to the minus x, as x goes to negative infinity, goes to infinity. So again, this is sort of like in the last example. We have infinity times infinity, right? The numerator is going to infinity, we rewrote the denominator as as 3 to the minus x, so we could multiply. So we got infinity times infinity. So I would predict that wait, this is h, not f, isn't it? I think I used it wrong up here as well. So let's make this was g. This was also g. This is h. Okay. So what's happening to h? I would predict that h of x goes to infinity. All right. All right, got one more here. We're just going to look at what happens as x goes to positive infinity. What's going to happen? We have 3e to the x, and that's going to go to infinity. And then we have the other term. We have this 7e to the minus x. All right, so now we have an e to the minus x, right? So it's like 1 over e to the x. 1 over e is less than 1, so this is going to go to 0. All right, so we can rewrite this also as 1/6 3e to the x minus 7e to the minus x. And so we're just taking whatever's happening inside the parentheses times 1/6. Okay, this one, the first term is going to infinity, second term is going to 0. So really the 3 e to the x is going to determine the outcome. And so k of x is going to go to infinity. All right, because essentially it's infinity plus 0, and then times a sixth, and then a sixth of infinity is still infinite. All right, and then let's look at the other side as x goes to negative infinity. What's happening now? Now this 3e to the x is going to 0, right? And now I'm going to write this as negative 7e to the minus x, all right? I could have written this one as negative too. I can always treat subtraction like adding a negative. So what's happening to this negative 7 e to the minus x? So we're taking the the exponent is minus x. So we're taking the negative of a negative. And so this is going to go to, in this part of it, 7e to the x is going to go to the, 7e to the minus x is going to go to infinity, but then we've got the negative of it. So this is going to go to negative infinity. So you can treat this as 1/6 e to the x plus a negative 7 e to the minus x. That's what I'm doing here. So when we do this, when we put this together, the 3e to the x is going to 0. The negative 7 e to the minus x is going to negative infinity. So 0 plus negative infinity is negative infinity. A sixth of a negative infinity is still negative infinity. So here k of x is going to negative infinity. All right. So that's all the examples I have, and I will see you in class for the discussion questions.